All right, now that you know what an ellipse is, we're just going to take a look at the basics of graphing. So you know the key components, you know some things about the proof that are going to help with that. We're just going to start today with a couple graphs that start at 0, 0. So we're going to have our center at 0, 0, which I can just plot right here. And then our A value is always going to be the largest value when we're looking for these different things. And if you looked back at the proof, we had that underneath the x, but we could easily switch up some things in the proof to make it underneath the y value. So the largest value, if we take the square root between the 81 and the 64, is going to be 9. Now, since that's the largest and it's under the y, that's telling you you're going to have a vertical ellipse. That's going to help us later on with the major axis. So what that means is that's kind of like your radius, but we're going up and down that value just for the y. So we're going to go up 9 and down 9 and plot points, similar to how you did graphing with the circles. And that's really the only component of the circle piece that we're going to look at here. The completing the square, we're going to look at the following day when we do notes when the center is not at 0, 0. And then the other value is going to be where the direction you're going to go on the opposite axis. So in this case, if I take the square root of 64, I get 8. That's underneath the x squared, so I'm going to go 8 across on the x-axis to the right and left. And this one will look kind of circular because 8 and 9 are not that much different, but it is stretched a little bit vertically. We can label our vertices and our co-vertices. Now, we have other vertices here, so our actual vertices are going to be on that y-axis. So we have 0, 9, 0, negative 9. Now, normally you could list those with plus or minus, at least for these, but I'm going to actually just add an extra space and list them separately. And then the co-vertices, or endpoints of the minor axis would be another name for them, are going to be 8, 0 and negative 8, 0. So this is going to be those two values. Endpoints of the minor axis are another name for co-vertices. So we have a major and a minor axis, which are all part of things that we defined when we looked at the ellipse initially. And then the only last piece that we have here are the things called the foci, which helped us to generate the ellipse initially with the string. So our calculations from the proof, we had the equation that said b squared equals a squared minus c squared. I'm just going to rearrange that. So I'm just going to swap the b squared and the c squared, or add and subtract. So I'll get c squared as a squared minus b squared. And this is the format we're going to use. It almost looks like Pythagorean theorem, but it has a subtraction in the middle. We're going to use that to find our c value, or where our foci are going to go. And you can use the original values right from the equation, because the equation has the a squared and the b squared in it. So it comes out to 17, which is a 4 and a little bit. So 1, 2, 3, 4. If I were to plot them, they would be there and there. And then they're going to be in the same line as the vertices. So it'll be 0, square root 17, 0, negative square root 17 for your foci. They are all along your major axis. So your major axis contains your foci and your vertices, and that's the equation of the line x equals 0 here. All right, we're going to take a look at one more graph that's going to be in the horizontal format, just so that you can see the difference between the two. And there's an added bonus that we have to get it in the right format. So the right format is that we have our equation equal to 1. So that's going to be important when we look at our next example. Okay, so in this example, we have 9x squared plus 16y squared is equal to 144. I want to do this one next. Yes, okay, so we're going to divide out the 144 for each of the values. Sorry about that. And that's going to get it equal to 1. We want it in that format because we need to know which is going to be the bigger number. So we're going to get x squared over 16 plus y squared over 9 is equal to 1. Now we notice the larger value is underneath x. So we're going to take the square root. We put the larger for A and the smaller for B. So A is always the larger number with the ellipse. And then this is under the x squared, so it's going to be horizontal. So now when I'm going to go left and right 4. So right 4 from 0, 0, left 4, and then up and down 3. Again, this one's kind of a little circular looking because the numbers are so close together. We have vertices of 4, 0 and negative 4, 0. And then we have the co-vertices of 0, 3 and 0, negative 3. It doesn't matter what order you put those in, by the way. And then we're going to go back and use that formula, c squared equals a squared minus b squared, to come up with the c value. So we get 7 for this. A lot of times your c value is a square root, but this time it's going to be square root 7 comma 0 and negative square root 7 comma 0. It will be on the same line as your vertices, so make sure that you have the same values for those. And if you plot them, they would be kind of close to those values. Now our major axis is going through the x-axis. So this would be the line y equals 0. So you should be able to try the other couple graphs here. And then the only other situation we have are the equations from the graphs. So for this, if we're starting with center at 0, 0, I don't know why that keeps happening. I apologize. It's getting annoying for you to look at and for me. We'll do x squared plus y squared. I'm just going to leave it equals 1. And then we're going to get the values. So this one is to the right 5 and left 5. So that means I'm going to put 5 squared underneath my x squared, or 25. And then I'm going up 2 and down 2. So I'm going to put 4 underneath my y squared value. And these are all going to be at 0, 0. So you just have to determine which one you have, horizontal or vertical, and put the bigger thing underneath. I think that should be fairly easy to see there. All right, so you now have a chance to try this practice on your own, either in class or for homework, depending on how much time is remaining.